Okay, so this is problem 7.5.52, and it states that in 1920, the record for a certain race was 46.3 seconds. Did I say 1920? Anyways, in 1920, that's what it was. In 1970, it was 45.8 seconds, and they want us to let R of t be the record in the race, and t be the number of years since 1920. Okay, so what we have, let's write down what we have. In 1920, they're telling us that the race was 46.3 seconds. That was the record. And then in 1970, it was 45.8 seconds. Okay. And what they want is they want us to allow R of t to be the record in the race. And then they want us to let t be the number of years since 1920. Okay, so what we need to do is we actually need to create, and I guess I didn't mention what they were asking us for. It's actually A, B, and C here, and let's work on A. A is find a linear function that fits the data. So in part A, we're finding a linear function that fits the data. FF is my abbreviation for function. Okay, so if we want to find a linear function that fits the data, we have to find an equation of a line. Essentially, that's what it's asking us for. So what we need to do is we need to take this information right here, and we need to create a couple of ordered pairs out of it. Okay, so since they're saying that t is the number of years since 1920, this would actually be a t value of 0, because 1920 is 0 years since 1920. 1970 would be a t value of 50. And then these are R of t values. Now what we have to decide, and actually they've already decided it for us, t is like our x value, that's our input value, and R of t is our output value, so that's our y value. Okay, so the ordered pairs that are going to come out of this, 1920 is going to be a t of 0, and our ordered pairs here are R of t. Okay, so it's going to be 0 and then 46.3. And then the ordered pair coming out of here would be 50, because 1970 is 50 years beyond 1920, and 45.8. Okay, so we're going to take these two ordered pairs and we're going to find the equation of the line. That's going to involve a two-step process of identifying the slope and then identifying the line. I'm just looking for some more scratch paper here. Okay, so let's take these ordered pair points. We have 0 and 46.3 and 50 and 45.8, and let's find the slope. Okay, so this is, I'm going to label this x1, y1, and this is x2, y2. And remember that your slope formula is y2 minus y1 over x2 minus x1. Okay, so if we plug these in, y2 is 45.8 and y1 is 46.3. That's all over x2, which is 50, minus x1, which is 0. Okay, and so if we use a calculator, we just have 45.8 minus the 46.3, so you're going to get a negative 0.5 here, and you're dividing that by 50. So you're going to get a negative 0.01. Okay. All right, and then what we want to do is we want to take this negative 0.01 and we want to utilize that with the x1, y1, the 0, 46.3, in order to identify the equation of the line. Now this is actually the y-intercept, so you could just stick that directly into y equals mx plus b, but for the sake of learning, why don't we go ahead and stick this into the point slope formula, because sometimes you won't be given the y-intercept here and you'll need to stick it into this formula. So this is y minus 46.3 equaling our slope negative 0.01 times x minus and x1 is 0. Okay, so this is y minus 46.3 equaling, if I distribute that, and actually this is just 0 here, so this becomes just a negative 0.01x. And then we would add the 46.3 to both sides so that this is in slope-intercept form. Typically we leave things in slope-intercept form. So we get y here is negative 0.01x plus 46.3. Now, they did ask us to use t and r of t, and actually I'm just realizing that I worked this whole problem in x and y, and that's fine. But let's go ahead and convert it because they did ask us to use the variables here. So r of t is our y value and t is our x. And so this would be the equation right here that you would need for part A. Okay. So that's the linear function that fits the data. In part B, if we go and look at part B, they are asking us for, they say use the function in A to predict the record in 2003 and then in 2006. And I'll just do 2003 because 2006 is done in the same way. And you can take a look at that. So part B, they want us to predict the record in 2003. And here's the function that we found. Okay. All right, so remember that t was defined to be the number of years since 1920. So if you take a look at 2003, this is going to be a t value of, it's 80 years up to 2000 and then 3 beyond that. So this is a t value of 83. So essentially you would be evaluating r of 83 in order to predict what the record's going to be in 2003. So if I plug 83 in for my t value, and then we're just going to do the math. So let's take that negative 0.01 times 83. You're going to get negative 0.83, and then we're going to add the 46.3 to that. So I get 45.47 there. Okay, and remember that the units on this are seconds because we're talking about it's probably, I don't know which race it is, but anyways, 45.47. Okay. All right, and then in 2006, obviously, you would do it the same way. You would just plug in t equals 86. And then let's do part C. In part C, they ask us, they want us to find the year when the record will be 45.40 seconds. Okay, so this time they're actually giving us, so when will the record be 45.4 seconds? This time they're actually giving us an r of t value. So this right here, r of t is 45.4, so that's a y value. And what we want to do then is we want to actually plug that in for the r of t in our equation and then solve for the t. So it's going to look like 45.4 equals negative 0.01 t plus the 46.3, and that's coming from this equation right here. Okay, so I'm plugging a value in, that value in for r of t, and then I want to now solve this for t. So we're going to subtract 46.3 from both sides. We get negative 0.01 t equal to, so we get a negative 0.9 here. Okay, and then if we're just going to divide by a negative 0.01, then we're going to get a t value of 90. But now remember, to actually answer their question here, you need to give a year, because they're saying when will the record be this, and t equals 90 is 90 years beyond 1920. So if we were to add 90 to 1920, we would get the year 2010. Okay, so that's actually the answer for part C there. Okay, so that's it on that problem.